Hi, Professor Baldwin here. Let's talk about linear functions and their slope, and maybe some applications of those linear functions. Remember that a linear function is going to be a function that can be written as a straight line. So we can write that as f of x equals mx plus b, where m is our slope and b is our y-intercept, and m and b are constants. The identity function would be the line y equals x, or f of x equals x. The slope is 1, and the y-intercept, or b, is the origin. It's 0, 0. And then we have the constant function, which is a horizontal line. The slope is 0, and the y-intercept is whatever that constant is for the line. So y equals b, or f of x equals b. Now, what about vertical lines? If you remember the vertical line test, whenever a vertical line crosses a graph more than once, it's not a function. So vertical lines are not functions. They don't pass the vertical line test. So we don't even consider them here because we're talking about functions. Now, remember the equation for slope. It's also referred to as rise over run, but I'd prefer you remember it as y2 minus y1 over x2 minus x1. It's your change in y divided by your change in x. Now, how do you find the slope if you're given 2 points? Well, we're going to use that y2 minus y1 over x2 minus x1. So I'll call this first ordered pair x1 and y1, and the second one x2 and y2. Remember, it doesn't matter just as long as your x1 and y1 are from the same ordered pair. So that gives us negative 6 minus 8 over 7 minus a negative 9. The numerator is negative 14, and the denominator is 7 plus 9, or we have negative 14 over 16. And this simplifies to negative 7/8. So the slope of the line that contains these 2 points is negative 7/8. How about example 2? We're not really given ordered pairs, or are we? Well, if you remember your function notation, g of this thing in parentheses equals a number. Well, the thing in parentheses is an x. So this negative 9/2 would be x1, and the output, 2/9, would be y1. And the same for the second function. So we know our x1 and y1 and x2 and y2, so we can plug those in. Negative 5/2 minus 2/9 over 2/5 minus a negative 9/2. Let's look at the numerator first. We need a common denominator between 2 and 9, 18. So 5/2, negative 5/2 becomes negative 45/18, and negative 2/9 becomes negative 4/18. Now let's look at that denominator. Well, the minus and the negative become a positive, and the common denominator between 5 and 2 would be 10. So 2/5 is the same as 4/10, and 9/2 is the same as 45/10. Now that we have common denominators, let's simplify the numerator. We have negative 45 minus 4, which is negative 49 over 18. And the denominator is 49 over 10. Now recall, when you have a fraction divided by a fraction, you keep that fraction in the numerator, you change the multiplication, and you multiply by the reciprocal of the fraction in the denominator. Well, notice the 49 in the numerator and the 49 in the denominator simplify each other out to 1. So this fraction times a fraction simplifies to negative 10 over 18 or negative 5 over 9. So, how do you find the slope if you're just given a linear equation? Well, remember, linear equations that are written in the format y equals mx plus b, the slope is this number m. So we need to rewrite this. Well, we have the y equals, just the 9 and the negative x are in the wrong order. So this is the same as negative x plus 9. And our m here is negative 1. So the slope for this line is negative 1. Now a quick reminder of what the different slopes look like. So a positive slope, remember we always read our graphs from left to right. So a positive slope rises when you read it from left to right. Negative will fall when you read it from left to right. Horizontal line has 0 slope, and a vertical line has an undefined slope. Remember that slope can also be considered an average rate of change. If you see average rate of change or rate of change, the question is talking about the slope. For example, annual per capita milk consumption in the U.S. was 25.3 gallons in 1970. By 2011, consumption decreased to 5.5 gallons. Find the average rate of change in per capita milk consumption. This just wants us to find the slope. And we have some points here. We have this point of 25.3 gallons in 1970. So our year is our x value. And 25.3, the gallons of milk, is our y value. And then we have this other point. In 2011, it was 5.5 gallons. So using that information, we can do the slope formula. 25.3 minus 5.5 over 1970 minus 2011, which is 19.8 divided by negative 41, which equals negative 0.48 gallons of milk per year. So consumption of milk is dropping by about half a gallon each year. Now remember, if you're given this slope-intercept form, f of x equals mx plus b, you can use that format or the y equals mx plus b format, and you can graph that equation just by using your intercept, b, and your slope, m. For example, 3x minus 4y equals 20. If we subtract 3x from both sides, we have negative 4y equals negative 3x plus 20. Divide by negative 4, and we end up in that slope-intercept format. We get y equals 3/4 x minus 5. First, we plot this y-intercept of negative 5. And then we can use our slope 3 over 4, which says every time we go up 3 units, we go to the right 4 units, and we get to our next point. We can do that a couple times, and then you connect the dots to get that graph for the linear equation. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos.